Now the topic, light, reflection and refraction. So these are the formulae related to mirror and lens. Mirror formula, 1 by f is equal to 1 by v plus 1 by u. And lens formula, 1 by f is equal to 1 by v minus 1 by u. The difference, if you observe here, mirror formula plus and lens formula minus, that's it. First v will come, then u. And magnification, m is equal to minus v by u is equal to hi by ho. This is for mirror. If you take convex mirror or concave mirror, whatever, it is the formula. Then for lenses, magnification formula, m is equal to v by u is equal to hi by ho. If you again, magnification for mirror minus, for lens there is no minus. Whereas in mirror formula there is a plus and here minus. And what is f? V and u. F means focal length of either lens or mirror. U means object distance. V image distance. HO means height of the object. H means height. O means object. Simply height of the object. Again HI, height of the image. H height, I means image. In some textbooks they give like a H dash by H, whatever it is. The formula remains same. So these are the formula in entire life chapter. Entire life chapter. And before starting the numerical problem, we need to read the question properly. Convex lens or mirror, focal length always positive. Always. Which means focal length of convex lens or focal length of convex mirror, focal length is positive. Concave lens or mirror, its focal length in this f, that is negative, means minus. Object distance u, always negative. Before starting numerical problem, these are the steps we need to take it. Sign convention. And image distance, it varies actually, depends upon mirror and lens. We can't say individually, yes, which one is positive and which one is negative. If you know the ray diagrams clearly, yes, I will do one more video for ray diagrams after completion of this. Yes. So these are the steps. First, before starting numerical problem, read the question properly. And you need to apply sign conventions. Convex means positive. Concave means negative. U means always negative. And in the given numerical problem, which type of lens given or mirror given, we need to understand. Let us start with one numerical problem. Yes. Here, one numerical problem is there. First one. An object is kept at a distance of 5 centimeter in front of a convex mirror of focal length 10 centimeter. Calculate the position and nature of the image formed. First of all, what it is said, before starting the numerical problem, we need to check with the given lens or mirror. Here, convex mirror given. Mirror, convex mirror. Convex mirror formula. So either convex mirror or concave mirror, mirror formula. 1 by f is equal to 1 by v plus 1 by u. Then convex mirror focal length always positive. We need to apply these conventions. And object distance negative always. Now start with the solution. First, always write given data. Here, object kept at a distance. Object distance given. Convex mirror. These are the keywords. Mirror is convex mirror. and object distance 5 centimeter, then focal length 10 centimeters. Now, given data, just write all these in detail. Given solution. Solution. Given object distance. Object distance represented by U is equal to 5 centimeters. So, what did I say? Object distance always minus. They will not give in the question which one is positive, which one is negative. Now, minus 5 centimeters. Then, focal length 10 centimeters. Focal length small f is equal to 10 centimeters. Now, the given mirror is convex mirror. The focal length of convex mirror positive. So, positive, no need to take it. Nothing is there here. It is a positive symbol. Even if you keep the symbol, also find out. Then what we need to find? Calculate the position. Position means image distance. Position, we need to find the position or where we need to keep the screen means image distance. Again, position or where we need to keep screen to get the sharp image. Sharp image means clear image. Now, image distance. V is equal to question mark. Right? The formula. Which formula? It is a convex mirror. No? For mirror formula 1 by f is equal to 1 by v plus 1 by u. Mirror formula 1 by f is equal to 1 by v plus 1 by u. So keep it in box. There. Substitute. 1 by f. 1 by f how much? 10. So here positive, I am not mentioning the symbol. This is equal to 1 by v we need to calculate as it is plus 1 by u object distance minus 1 by 5. Right? Our aim to find the v value. So whenever this 1 by minus 5 comes this side, convert it into plus. Notice that implies 1 by 10 plus 1 by 5 is equal to 1 by v. Now, LCM for 10 and 5. Take the LCM for 10 and 5. So 5 table, 5 1 times, 5 2 times. Then finally 2 into 1 into 5. 2 into 1, 2, 2 5s, 10. So the LCM is 10. 10. Now 10 and 10. How many times? 1 time. Plus here 5 and 10, 5 2 times. 2 into 1 2 is equal to 1 by v, which is equal to 1 plus 2, 3 by 10 is equal to 1 by v. Therefore, v is equal to, then this is 1 by v equal to 3 by 10. Then v equal to reciprocal is 10 by 3. So 10 by 3 means approximately v is equal to 3 times 9. Then again 6. Then 3 times 9. 1 will come again 0.10, 3, 9, 3. So it will go on like this. So therefore 3.33 centimeters. Now here we got image distance in positive value. Positive means convex mirror. Positive is a virtual image. Now, your position at 3.3 centimeters. Now, the nature is virtual image. And all virtual images are erected images. Virtual and erected images. So, this is the image listing. This is the image. So, first what we need to do? Formulas and read the question properly. What is the lens or mirror given? Okay. One more numerical problem. Light chapter. Here, an object is kept at a distance of 30 centimeters in front of concave mirror. Previous convex mirror, now concave mirror, and the focal length 20 centimeters. Calculate the position and nature of the image form. Now, object distance 30 centimeters. Object distance always minus. See, object distance 30 centimeters minus 30 centimeters. Don't forget. Minus the focal length. Concave mirror focal length always negative. Concave, either lens or mirror, its focal length negative. Keep in mind, very, very, very important. Focal length minus 20 centimeters. They did not mention sign convention. Just we need to mention the sign. Object minus focal length minus for concave. Now, image distance question mark. It is a convex mirror. Mirror formula 1 by f is equal to 1 by v plus 1 by u. Now substitute. M by f 1 by f value minus 20 is equal to 1 by v plus 1 by u value minus 30. Now, here 1 by minus 30 come the side, then 1 by minus 20 plus 1 by 30 is equal to 1 by v. Now take LCM for 20 and 30. The LCM for 20 and 30. What is the common table in this? 10 table, 10 twos and 10 threes. Then LCM is 3 into 2 into 10 is equal to 3 twos 6, 6 into 10, 60 LCM. Now implies LCM 60 is. Now here minus symbol is there. Keep it minus 20, 60. How many times? 3 times. 3 into 1. 3 plus as it is. 30 here, here 60. 30 and 60 how many times? 2 times. 2 into 1, 2 is equal to 1 by v as it is. That implies minus 2 plus 1 minus 1 by 60 is equal to 1 by v. Here minus symbol belongs to whole fraction. Therefore, v is equal to minus 60 centimeters. That is always formula and answer, keep it in box. Here concave mirror, image distance negative means it is a real image. All real images are inverted images. Now, image distance is 60 centimeters and it is a real and inverted image. Okay. One more numerical problem related to lenses. Very important numerical problem. Here two topics are covered: magnification as well as image distance. An object height of 6 centimeter is placed perpendicular to the principal axis of a concave lens of focal length 5 centimeters. Use lens formula to determine the position, size and nature of the image if the distance of the object from the lens is 10 centimeter. Right. But what is this one? Object height. That is not object distance. Here. First, what is the lens? Concave lens. Concave lens, focal length negative. First, write the given data. Given object distance, image we need to find, focal length all we write. First, this is height of the object. Height of the object equal to 6 centimeters. Height of the object HO equal to 6 centimeters. Then focal length of lens 5 centimeters. Here 5 centimeter focal length concave minus, and here object height always positive. Then distance of the object from the lens. Object distance 10 centimeter. Object U always minus object distance. Now use the lens formula. What we need to find? Find the position and the size. Position means V. Size means height of the image. Position means size. Size of the image means height of the image. Then position means image distance. Image distance question mark, height of the image question mark. Here two formula we need to use. What are those? To find the image distance, lens formula minus lens formula 1 by f equal to 1 by v minus 1 by u. Then magnification for lens m equal to v by u, which is equal to height of the image by height of the object. See formulas. Equal to 1 by v minus 1 by u, height of the image by height of the object equal to v by u. These two formulas we need to use. Now first, from this 1 by f equal to 1 by f equal to 1 by v minus 1 by u. What is the f value? Minus 5. That implies 1 by minus 5 equal to v. We need to calculate 1 by v minus 1 by u. U object distance. Object distance is minus 10. 1 by minus 10. Here minus of minus plus. If you change this one, it will come like this. then it can be taken as minus. Don't confuse, I am writing one more step. 1 by minus 5 is equal to 1 by b plus 1 by 10. Now plus 1 by 10 comes beside, see, 1 by minus 5 minus 1 by 10 is equal to 1 by b. Again, what is the LCM for 5 and 10? Already we did previously. Same way 5 ones, 5 twos. The LCM is 10. That implies 10 minus 5 table how many times? 2 times. 2 into 1, 2. Minus as it is 10, 10, 1 time. 1 into 1, 1 is equal to 1 by b. Now, minus 2 minus 1 minus 3 minus 3 by 10 is equal to 1 by b. Now, this is v equal to minus 10 by 3. 10 by 3 means which is equal to 3.33 centimeters. This is the image distance. Now, we need to calculate height of the image. Which formula we need to use? This one. Height of the image by height of the object equal to plus v by u. If it is minus, that is the formula for mirror. Now, in second step, image by height of the object equal to v by u. Here we need to substitute. From this, height of the image equal to v by u into height of the object. V by u into height of the object. So this is in denominator and this comes to set here. Changes it to multiplication. V by u into height of the object. Now substitute the values. What is the v value here? V value we can take minus 3.33 minus 3.33 minus 3.33 by object distance. Object distance minus 10 into height of the object. This is 6. Height of the object 6. Now, here minus gets cancelled. See here 3.33 by 10 into 6. It takes some little bit confusion. So that this I'll change it as. Here 3.33 value we got from 10 by 3 no. So that instead of 3.33 I am writing 10 by 3. 10 by 3 whole by 10 into 6. Again I am explaining 3.33. In that place I changed it 10 by 3 for simple calculation by 10 as it is into 6. Now changes it 10 by 3 into, this is 10 now. It can be written as 1 by 10 into 6. It is very simple. See, there are two fractions actually. 10 by 3 by, here 10 by 1. 10 by 1. This 10 by 3 as it is into, this is reciprocal. 1 by 10 into 6 as it is. See how the simple calculation. 10 gets cancelled. 3 ones, 3 twos. Simply the answer is 2 centimeters. Got it? So in this way we calculate. Here it is the positive value. Now it is virtual image because the lens is concave lens. Concave lens always forms virtual image. Virtual image, and here the height of the object is 6 centimeters. Now the image height is 2 centimeters. So the height of the image less than height of the object. So this is diminished image. And if you get the value in positive, that is virtual. Now the characteristics are, it is virtual, and all virtual images are erected, erect, and diminished image. And diminish. So these are the very important concept. If you have any doubt, once again you comment in the box. And it is one model. Here in the next video, I will explain magnification as well as this is concave, no, convex lens. 3 more numericals will do. And so now the video length somewhat more. You pause it. Step by step, you look into it very carefully. And these are the formula and sign conventions. Yes, thank you.